Greetings, everyone. Today I'm just going to kind of do a brief review of how to illustrate a Bohr model for a particular element. And just a brief review, we know that the Bohr model is a primitive illustration of how, or a basic illustration of how an atom is, the components of the atom. We have our nucleus, and then we have electrons that would occupy the levels around the nucleus. Now, with the more current illustrations of an atom, we know that electrons do not have a direct pathway that circulates around the nucleus, and more of a cloud that the electrons occupy those spaces. But in the meantime, let's just kind of go over the illustration that was created by Niels Bohr. All right, so we have magnesium-24. And if we remember, the number after the hyphen is the mass number. The number after the hyphen would be considered our mass number. So what I like to do is kind of just have P, E, N, where we have our protons, our electrons, and our neutrons, and what those are. So when we look at our periodic table of elements, we see that magnesium is number 12. And number 12 is our atomic number. And the atomic number tells us the number of protons within our nucleus. So we know that our protons are 12. And since we're dealing with a neutral atom, which means there's no charge to our atom, we know that our electrons will also be 12. Now, in order for us to find out our number of neutrons, we know that we have to do mass number minus the protons, or our atomic number, which would then give us our number of neutrons. So our mass number is 12, number of protons is 12, so 24 minus 12 will then give us 12. All right? So now that we have the amounts for each subatomic particle, so protons will be 12, electrons are 12, and neutrons are 12, let's fill our diagram. And so we can account for our nucleus with the protons. So our protons are 12, and our neutrons are also 12. So now we know that we have our nucleus completed. So now let's start to distribute our electrons. When we reference back to our table, the first level holds a maximum of 2. Our second level holds a maximum of 8. 3 holds a maximum of 8, and 4 holds a maximum of 18. That doesn't mean that the orbital level can't hold less, but it cannot exceed the maximum capacity. And also remember, when we talk about in the future off-bow principle, we can't move to another orbital without completing full capacity from the previous level. Just like a video game, I'm not going to go to level 2 without having level 1 be completed. So we want to keep that in mind. So let's go back to our example. So level 1, which is this first ring here, we're going to occupy that with two electrons. So I'm going to mark that with an X, mark that with an X. Okay, so that's 2 electrons. Now, I need to get to 12 though, but I'm only at 2. So now let's go to the next level, because I cannot hold more than 2 on my first level. I need to go now to my next level. So now that I'm on my next level, I'm going to add 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm at 10, still not at my goal, 12. But I cannot exceed 8 on the second level. So now if my maximum capacity is at level 2 is 8, I need to go to my next level. So now I'm going to go to level 3. And now I'm going to put my 2 electrons that I need to have there. Okay, so let's go over it again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have now effectively illustrated the amount of electrons that are orbiting my nucleus through the Bohr model. Okay? I hope this helps. Have a good day. Bye.